Factor 4x squared minus 12xy plus 9y squared. I'm going to rewrite this down here. Now this is a trinomial, and the leading coefficient isn't 1, so we can use the AC method here. And it might seem a little bit different because we've got two variables, but we're still able to use the AC method. Let's see how we can adapt this for problems where there are two variables. In this case, AC is going to be 36 because A times C is 4 times 9, and 4 times 9 is 36. And B is negative 12. So we're looking for two numbers that have a product of 36 and a sum of negative 12. Those numbers are negative 6 and negative 6. Now when we use the AC method, we split up the middle term. And we're going to do the same thing here. That 4x squared is going to stay 4x squared. But that negative 12xy is going to become negative 6xy minus another 6xy plus that 9y squared. When we use the AC method and there's more than one variable, when we split the middle term, we're not going to be splitting up the variables. We're not going to have the x go to one and then the y go to the other. The variables are going to stay the same. We're just splitting up that coefficient. Negative 12 is negative 6 and negative 6. And once we've done this, we can finish off by grouping, just like the ones with one variable. If we look at the first group, both of those terms contain a 2x. So the GCF is 2x, and then the leftovers are going to be 2x minus 3y. Now, if we look at the second group, both of those contain a 3y, but we want to pull out a negative 3y so that the signs match. If we pull out a negative 3y, that leaves us with a positive 2x, and then in the second term, a negative 3y. So because we have the same thing in each set of parentheses, that becomes the GCF of the groups. Both of those groups have a 2x minus 3y, so we can pull out 2x minus 3y from the groups. And when we do that, the leftovers are 2x from the first group and negative 3y from the second group. So in the end, we end up with 2x minus 3y times 2x minus 3y, or some of you may have noticed this is 2x minus 3y, quantity squared. This happens to be a perfect trinomial square, just like we saw in the last section, and it does end up being a little bit more work using the AC method here. If we had recognized this as a perfect trinomial square, we would have been able to factor it in much less time and with much less work. But this still works.